Let's recap a few things that we've talked about so far in this course. We've discussed collecting a sample and how we might describe that sample, both graphically, with some plots like histograms, and numerically, with measures of central tendency like mean, median, and mode, and measures of dispersion like variance and standard deviation. Then we talked about random variables, which, as it turns out, describe those samples that we collected in the first place. If a phenomenon doesn't exhibit randomness, then we don't need to collect several observations to describe it. That is, if we're trying to describe the number of wheels on a bicycle, we don't need to collect a sample of bicycles and count the number of tires, plot our observations, and use an average to describe it. We only need to produce graphs like histograms for phenomena that exhibit randomness, and the measures of such phenomena are described with random variables. So we discussed that in somewhat of a backward order. But it's easier to start out with a simple task like data collection and motivate measures like mean and standard deviation from data that we've collected. Then talk about random variables and their distributions. Now that we know more about distributions of random variables, let's revisit sampling. This unit helps us bridge the gap between probability and inferential statistics. We previously said that probability was the study of the likelihood of different events, and inferential statistics was the study of how we can describe a population based on a sample. And the concepts of probability and inferential statistics are tied together here with a discussion of sampling distributions. No longer is the mean a quantity that we just compute for a sample data set. We'll see that it's actually a random variable that follows a distribution.